A thin piece of wire 40 meters long is cut into two pieces. One piece is used to form a circle with radius r, and the other is used to form a square. No wire is left over. Which of the following represents the total area in square meters of the circular and square regions in terms of r? So this is a question that I think sounds, maybe even looks, based on the answer choices, harder than it is. If you just sort of take that first step of visualizing what is going on here, things sort of fall into place very nicely. And so to start, what do we know? We just have a piece of wire, a straight piece of wire that is 40 meters long. And then we cut it into two pieces, and we don't know where we cut it. So I'll have one piece here, one piece here. And so let's say this guy here has a length of x. What must be true about the other piece? Well, this must have a length of 40 minus x. And so remember, despite the way I drew this, we have no idea what these two pieces actually look like. We have no idea if this is the longer one, this is the longer one, if they are similar in length. We don't know any of that. But regardless of what they actually look like, this will always be true. If one has a length of x, the other is going to have a length of 40 minus x. And then from there, so we got to one piece that is formed into a circle. And then the other is formed into a square. And we want to get everything in terms of r, not x, because I just made up this x here. So we got to get rid of this x, replace it with an r. So what do we know? So we're looking for the total area. So that should just be the area of our circle plus the area of our square. And we know our circle has a radius of r. So what is the area of this circle going to be? It's just going to be pi r squared. And so if you look at our answer choices, they all start with a pi r squared. Why is that? Well, that's because that's just, they practically just give us the area of our circle. And so what's left must be just the area of the square is really where all of our work comes into play. So, what does this mean? So this x here, remember? So we took this wire here that had a length of x and we bent it into a circle, which means this x over here is actually the circumference of our circle, right? So if we want to replace our x over here with an r, we need to get an equation of our x in terms of r. And so we can say x, the length of my piece of wire, is equal to the circumference of my circle, which is just 2 pi r. And so now over here, we can say instead of this piece being 40 minus x, it is 40 minus 2 pi r in length. So we bent this piece of wire into a square, right? So if this had a length of 40 minus 2 pi r and a square has 4 sides that are all equal in length, each side of our square should be 40 minus 2 pi r divided by 4. What is that? That is 10 minus 1/2 pi r. So this is sort of why I say this question is a little bit easier than you might think, because now you might be groaning saying, okay, I want to find the area of this square that's its length times width, and I'm going to have to multiply these guys out, but you don't have to, because if you look at our answer choices, E is exactly what we are looking for, just not fully multiplied out. And so our total area should be the area of our circle, which is pi r squared, plus the area of our square here, which is 10 minus 1/2 pi r times 10 minus 1/2 pi r, also known as 10 minus 1/2 pi r squared. So we really do not have to multiply it out, and E is the answer.